I'm going to be talking about the Bluzelle database today. So what is it? It's a decentralized key value store. If you've used Redis, think of a decentralized version of that that runs on blockchain technology. So we don't actually run on top of a blockchain. It's a question that comes up often. We use decentralized trustless technologies to build swarming technology to power a database. So I'm going to be talking a little bit also about the data economy, which is the slide you see here. And the data economy, real quick, is kind of our phase 2. We've already released the Lovelace version of our database. We released the first version on July 2nd. What we're trying to do now is build some higher level constructs so that people can use the database in the context of the data economy. So I'll talk about that briefly. And time permitting, I'll try to show you a quick demo of a Solidity application that's using Bluzelle. So quick history, we started the company in Canada in 2014, moved the company to Singapore in 2016, and both myself and my co-founder, Paolo Baines, are from Silicon Valley originally. That's where we kind of worked in our careers, but we're both based in Vancouver, British Columbia, and that's where all our development happens. That's us sitting in an office in Singapore, and we came with our backpacks and nothing else. We did our ICO in January of this year. And the ICO token powers our database. These are some of our clients. We built a KYC product in Singapore. And one of the reasons we needed to build a database is we realized that the blockchain is actually not a very suitable database. You can't change the data, it's immutable, and it's expensive, high cost, and the latency to store data on is very high. So if you want to build a KYC system for a bank, it just won't work. This is our team. Myself and my co-founder. And real quick, our advisors. We have some excellent advisors. These are 4 of the advisors I work with the most. Brian Fox. How many people in the room have heard of Brian Fox from the Free Software Foundation? And he's also the author of Bash. He loves to also hear that people know he wrote Finger. So if you guys use Finger from back in the day. Ryan Fugger actually is a Canadian, and he wrote the original Ripple protocol. So he's one of our advisors. He's helping us with consensus algorithms. Prashant Malik, he was at Facebook, and he's one of the co-authors for Cassandra. So obviously having someone with that background is fantastic on our team. And then Alex Leverington, one of the developers, or the core developers at the Ethereum Foundation, he helps us across the board with everything that has to do with blockchain. So the problem really right now is people don't realize that when they're using services like Facebook or Google or Amazon or anything, they're volunteering their data. It's not a free service. Your data is actually a currency. So when you're giving your data, you've got these drones or Borg drones or whatever, they're assimilating all your data. And this is a slide we got from The Economist, just full disclosure. But we love it because this is what's going on. There's big titans now that run the internet, and it's not decentralized, it's actually quite centralized. And we're trying to push things back in the direction they should be. So phase 1 was our database, which is something I'm going to talk through. And yeah, so 2 of our key hires that we had recently, someone from NASA, Isabel, our researcher, and then Andrew from Pertino. So as you know, in the past, you had a single system model. If anything went wrong in that corner, you were in trouble. Your system went down. We've got the cloud model in the middle, and then the future model is this swarming model, where each of these are swarms. I know it doesn't look like a swarm, but you'll have to believe me. And within each swarm, if a node goes down, it's fine, because the swarm has many other nodes, and your data is fine. So your data basically gets chopped up and stored into these swarms. So you get enhanced reliability. Your data is stored across the swarms, and security, and on-demand scalability. Your data is going to scale across the swarms as it increases. And of course, there's a cryptoeconomic model behind this. The whole point of the token, at least from this perspective, is for people to run nodes, and they get compensated with Bluzelle tokens to be farmers. We call it farming, not mining, because you're not actually mining anything. So it's actually quite light in terms of usage of your CPU. You don't have to have a powerful CPU to become a farmer. So this is what I was talking about. Data is now a currency. So phase 2 is building this new data economy. Talking about a data wallet where your data is protected now. It's stored in a wallet, and that's how you protect it, just like any kind of cryptocurrency. So you can click on a button, and it's like a kill switch. It's like the right to be forgotten. And this is something that's really important with laws like GDPR that have just come out in Europe. And in North America, where I'm from, there's already jurisdictions that are starting to do this. California just passed a law about 2 weeks ago, rushed it through the Senate to get privacy laws passed through at the state level. So these things are happening everywhere, and we have to be prepared for it. So storing data on the blockchain, not an option. And the data marketplace is a means to syndicate data. So imagine that you have data that you want to sell to others. You have GPS data, OpenStreetMaps, Yelp data, whatever. You can publish it now as a syndicator onto our database, and it'll get onto a marketplace. Now, whenever somebody uses that data, you'll get compensated for it with Bluzelle tokens. So this is the data wallet flow. I'm not really going to run through it due to time constraints. But basically, Alice's data goes through a data wallet, and if Ethereum, which is a fictitious social network, wants to use that data, it'll have to ask the data wallet for permission. The data marketplace is very similar with the addition of the data marketplace installed in there. So now, if somebody wants to access that data, they have to go through the marketplace, and it's like they're buying the data, and again, there's a cryptocurrency driving this. And the decentralized web infrastructure is something that I'm very interested in, because one of the key aspects of the internet right now is if you go through the World Wide Web and try to go to a website, it's not decentralized. You have to deal with name servers. You have to deal with centralized web servers that are storing content. One of the challenges we had when we were running our ICO was we don't want somebody to hack the website where the ICO's Ethereum address is listed. So that's something that still needs to be resolved, and this is something we're working on, is using our database and working with other partners to decentralize the web experience. So the token velocity, many different places. You know, data wallet providers, data marketplaces. If you publish data, you can earn tokens. And of course, if you're actually running a node as a farmer, you earn tokens. So right now, we're running 7 nodes. That's for our Lovelace release. And you can add nodes. So that's the whole point, is for scalability, is that you can add nodes. And these yellow ones on the sides are the nodes that have been added. We're using Microsoft and Azure and BT. These are 2 of our partners. So they provide us resources. So we have quite a bit of resources to kickstart and bootstrap this whole network. And that's what we're doing right now. I'm going to skip these slides. But here's the metaswarm. So even though it looks like there's a swarm sitting here in the middle of the Indian Ocean for some reason, and some nodes sitting in North America, and there's one in Greenland or something, these swarms are actually covering the entire world. The point is for each swarm to be geographically distributed so that they act like a CDN in a way. If you pull your data is going to come from the swarm nodes that are closest to you. And of course, you have the redundancy. If a big tsunami comes and knocks out the west coast of North America, your data is still protected. It's not like there's a swarm that's only sitting there. So imagine you have your key value pairs, and they get partitioned. So it's horizontal partitioning for those of us that have looked at that kind of data. I'm going to show you a quick visualization here. Let's see. So this is a dashboard that we built recently. And what it's showing you is the health of the network. So this is connected to our testnet. It's showing you things like the total database size, total key value pairs, number of commits, number of peers, latency. The reason we have this is we want to have a public tool that people can go in and they can look and see what's going on with our database. It's going to be improving over time, but one of the things I like to point out is that the key value pairs and database size can go up and down. And that's because the database is mutable. You can remove data from it. Unlike a blockchain that technically keeps growing without bounds, this database doesn't. So you can remove data from it if you want to. And what I'm going to do now is, I've got about a minute left before questions, but what I want to show is a demo of using the database, let's see here, from an Ethereum smart contract. Now, let's see if the internet's going to behave with me here. Right, so what I've got here is a smart contract, and I'm going to be presenting this in more depth in the workshop later on today. But I've already deployed a smart contract to Robston, and what I'm going to do is I'm going to write a value to it. So I'm just going to put in, I don't know, the name, the key value, key of France, and the value Paris, and I'm going to write it. And what I'm doing now is I'm writing a transaction to the blockchain, and it's going to be picked up by something called Oracleize. That's going to then transmit it to the Bluzelle swarm. So let's submit it. And what we'll do is, while we're waiting for this, I'll start to take questions, because this is going to take a couple of minutes. We have to wait for confirmations. So yeah, let's start with the questions.
And it is, how do you compare it to IPFS?
Yeah, number one question that always comes up. So IPFS is, it's not a database storage mechanism. I mean, we actually want to work with IPFS for the decentralized web aspect. And the reason I say that is IPFS is basically an addressing mechanism for files, but there's no necessary guarantees with IPFS that whatever address you're looking at is even going to be available. There's no availability guarantees. And what we want to do here is actually provide that database layer in conjunction with IPFS as opposed to competition. So, for example, imagine you go to a website, you want to be able to pull HTML files, JavaScript, you want to pull video files, those would come from IPFS. But if you want to pull anything that's dynamic in nature, like user data, anything that is stored on a database, it would come from Bluzelle. So I don't look at them as the same thing. They actually complement each other. Next question.
If anybody has one from the stage, you can go ahead and... Okay, oh, there's another one. So what operations depend on Ethereum and its limited throughput?
Say that one more time.
The question is, what operations depend on Ethereum and its limited throughput?
None of the operations depend on Ethereum. Bluzelle is not built on top of Ethereum. So the demo that I'm showing you right now is something we explicitly built to support Ethereum. We don't actually depend on Ethereum or any blockchain. So we actually explicitly built a bridge so that you can make requests from Ethereum and use Oracleize, which is a bridging service, to talk to our swarm. But quite frankly, a lot of the applications that have come out of the hackathons that we've run were not using Ethereum or any blockchain. They were actually built in traditional environments like Python, JavaScript, even mobile applications on iOS and Android. So we're not constrained by that. You can make direct connections with WebSockets.
Cool. There's another question that just came in. So the question is, does it involve some kind of encryption for the data wallet?
Yes, your data will be encrypted. That's a key aspect of the data wallet. The data wallet has to protect your data, keep it away from people that are unauthorized to see it. So yes, we're going to be putting native encryption into the database. It's not in there yet. So the data wallet is going to be something that's coming out not in this half of the year, but the next half of the first half of the next year. So real quick, I'm just going to do a quick context switch here. Some of you might have observed that I wrote the key and value Paris, France and Paris. And now what I did is I came to the Bluzelle client here, and I just pulled it up. And there you go, it says Paris here. Now if I put in tour in here and save it, I'm going to try to pull it up now. What I'm basically demonstrating here is I changed the value of a key value pair off Ethereum, and I'm going to read it back in to show you interoperability. So I'm ready for the next question.
Yep, let me check. Right, so there's a new question in. It's asking, how is a swarm different from a AWS region?
That's a good question. So a swarm, I don't want to be quoted on exactly an AWS region, because I don't have the definition, but a swarm is not a region. A swarm actually covers the entire globe. When you join a swarm, the node membership function that decides which swarm you're joining actually determines which swarms are going to benefit most from you. And one of the factors is which swarms have the most to gain from you being added. So let's just say you're joining a swarm here in Germany, in Berlin. We will look for the swarm that has the most to gain. Maybe it has a weakness in this part of the world, and we will add you to it. So there is no regionality, so to speak, in a swarm. Swarms are supposed to be as geographically spread out as possible.
Cool. All right, we have 1 more minute, so if you want to just quickly wrap up the demo there.
Okay.
And I apologize for the person that just asked the question there.
No problem. There's more questions?
Yeah, no, I was just thinking if you could wrap up the demo.
Okay.
I don't think we have time for the last question.
I just submitted a read. I probably will not have the time to wait for the read response. But basically the way it works with Ethereum before I close out is if you want to do a read, you make a request, it goes out to Oracleize, the request is made, and then you wait for the callback. The callback comes back with the response for what you're asking for.